Now we're going to get to radians. And again, radians, it may not be as intuitive. It turns out to be mathematically better than degrees. They do go more into it in the textbook than I'm going to go into. And there is actually a formal definition of what a radian is. For time consideration, I'm going to skip over that formal definition, but I'm just going to show you what you need to know for this class. Basically, all I'm going to show you is how to convert between degrees and radians. I mean, there is a formal definition of what a radian is. And again, it's mathematically better. So if you did go into calculus eventually, you will work with the trig functions there, and you're only going to work in radians. But that's a different story. What does turn out to be true, though, is 180 degrees is the same as pi radians. Pi does represent a number, but we're going to leave it as pi. So 180 degrees is the same as pi radians. And from here, you can actually express 1 degree in terms of radians. 1 degree is pi over 180 radians. The 1 degree is pi over 180 radians. And you can go the other way around. If you divide by pi, you get 1 radian is 180 degrees over pi. 180 over pi degrees. Like so. And really from here, we're going to convert between degrees and radians. If you want to convert from degrees to radians, you want to multiply by this quotient, by pi over 180 degrees. That's if you want to go from degrees to radians. And if you want to go the other way from radians to degrees, you have this. 180 degrees over pi. That's if you want to go from radians to degrees. I mean, you will have, I did email you guys the notes, so you should have it in your inbox. Let's say, since the quizzes and exams here are open book, I guess you really, for this class, you don't have to memorize what to multiply by. But if you want your answer to be in radians, and the way I remember it is, I would want degrees in the denominator. So if I want my answer to be in radians, which of these do I use? I'm going to use this one because I don't want degrees in the answer if I want my answer in radians. If you have degrees in the denominator, odds are it's going to cancel. I mean, I hope that helps, but and likewise, if I want my answer to go from radians to degrees, by degrees I want in the numerator. But then I don't want it to cancel. Again, the notes you'll have in front of you in this class at least, so you don't have to remember that, I guess. Because usually if you don't, like in the classes normally that I teach, on campus, it would be a closed book test, so you would have to remember which one. So, all right, anyway. But again, it's not the formal definition of radians, but for this class it's enough. You can convert from one to the other. Also, notice here I didn't write pi radians over 180 degrees. People don't generally write out radians if the angle is in radians. The degree symbol they will use, as you can see, like here we have 180 degrees. So the degree symbol they will write down, or write out degrees, I guess. But radians, they don't. Usually from the context, it's going to be clear if your angle is in radians or degrees. And that also reminds me, in your calculator, when you're working in this section, make sure your calculator is in the right units. If you want your answer to be in radians, but the calculator is in degree mode, your answer is not going to be right. Just something to watch out for. Also, notice that pi I didn't write as a decimal. Don't do that either. You don't want to write pi here as a decimal. I know it's tempting. I've seen people do that, but you don't do that here. Okay. So here, I just did some examples. It's from the last class mostly. Mistake here at least. 90 degrees, right? What would that be in radians? So again, I wrote here, don't convert pi to decimal form. So for 90 degrees, I want to write that in radians. So what do? I multiply by pi over 180 degrees, as you can see. When I do that, the degree symbol vanishes. You can think of that degree symbol as canceling. We're left with 90 pi over 180. But 180 is 90 times 2. So I'm basically canceling a bit, right? 180 is 90 times 2. When I write that out, the 90s cancel. We're left with pi over 2. Again, notice I didn't write pi over 2 radians. But there's no degree symbol here, so it's understood to be in radians. 270 degrees, right? Same idea. I'm going to multiply by pi over 180. 108, excuse me, pi over 180 degrees. The degree symbol, as you can see, that's going to cancel. It's gone. 270, right? Pi over 180. I can reduce this because 270 turns out to be 90 times 3. 180 is 90 times 2, right? So the 90s we cancel, we get 3 pi over 2. Down here we're in radians, although again, I guess didn't have to write radians here, but that's okay. If you write down radians after your angle, I'm not going to take points off. I wouldn't do that. So here, 2 pi over 3 radians, we want to write that in degrees. I'm going to multiply by 180 degrees over pi. The pi's cancel. That's what I'm writing here. We have 2 times 180 degrees over 3. And when you do the calculation, you end up with 120 degrees. Notice the degree symbol is here. Okay? So we know our angle must be in degrees. Here we have pi over, that was a 3, but it should have been a 6. That's why I wrote it this way. Pi over 6 radians, right? Same idea. We want to convert it to degrees. So we're going to multiply by 180 degrees over pi, as you can see. Okay, so what happens next? The pi's cancel, as you can see, right? The pi's cancel. We have 180 degrees over 6. That turns out to be 30 degrees. Pi's cancel. I mean, people usually have pi degrees. They just don't write that as far as I know. So, but again, we have the degree symbol here. Okay. The next slide I was going to have you guys try, but me being the knucklehead that I am, the notes I sent had the answer to this. So I figured it'd be good if we do this together. 45 degrees, right? Same idea. We want to convert that to radians. So we're going to multiply by pi over 180 degrees. Right? Again, we want to go from degrees to radians, so we're multiplying by this. What do? We multiply, and what happens? The degree symbol is gone. You can think of that as canceling. We're left with this. 180 is 4 times 45, right? So we're reducing it. So the 45s cancel. We're left with pi over 4. Again, also, we're going from degrees to radians. So we want pi in our answer. So odds are we're going to have pi. So that means we really want pi in the numerator. So that does kind of give you another way to multiply of which conversion factor to use. This or, where is it? This, 180 over pi. You know, if it's in the denominator, then it's going to cancel, odds are. Right? We want the degree symbol to cancel, so we want that in the denominator. So from here, as you can see, we have another example. We're going to multiply this by pi over 180 degrees. And again, we multiply by that to convert into radians. How do I know to do that? Well, it's on the previous slide, but also by doing this, the degree symbol is going to cancel. And that's what we want to happen. We want that to happen. So what we get is this. And again, you can reduce this. I mean, if you left it like this on a quiz or exam, that would be okay. Although in Lumen Learning, I might have you simplify it though. But we'll see. But with a test or anything that I'm grading, if you left it like this, that's fine. But again, you can simplify this. Because 135 is 45 times 3. 180 is 4 times 45. Let me see something. Okay, I was worried the background noise would be too loud, but I don't think it is. Okay, so we have that. So we get 135 is 45 times 3. 180 is 45 times 4, right? So you can see that the 45s are going to cancel. And we're left with 3 pi over 4. That's what we're left with. So from here, okay, that's what we get. We get 3 pi over 4. Again, I didn't write out the word radians, okay? If you did with me, it wouldn't be an issue, but generally people don't do that. Pi over 3, right? I want this to be in degrees. So I'm going to multiply by 180 degrees over pi. Why is that good? The pi's cancel. I get 180 degrees over 3, which is 60 degrees, right? That was different. Okay. I thought I did this one already, but I didn't. Next one, 5 pi over 6, same idea. We multiply. Like so. The pi's cancel. This should be a 6. I don't know. I think what I did was I copied this down here when I was making my lecture notes, and I forgot to make this into a 6. I'm sorry about that. But we get 5 times. When you multiply like so, the pi's cancel. We get 5 times 180 degrees over 6, as you can see. So we have 5 times 180 degrees over 6. And if you do that, you get 150 degrees. Same idea here. You multiply by 180 degrees over pi because you want your answer to have degrees in it. The pi's cancel, as you can see. So we end up with 2 times 180 degrees over 5, which is this, which is 72 degrees. This I did in my calculator. But again, we multiply by 180 degrees over pi, and then the pi's cancel. And then we're left with this.